Dear students, very good morning. As we were doing some of the standard integrals in the previous video, we have seen some formulas which I have explained you, which I have written, and I told you to just see the proof of those 7 standard integrals, and we have done certain questions. In this video, we will be focusing on those questions only related to those 7 standard integrals. Okay, so try to focus, try to just concentrate how the question is being done. Okay, do along with me, take a copy and pen and do the questions. So the very first question I'm taking as integration of x cube upon under root 1 minus x to the power 8 dx. Now how to solve this question? So we will be using very different logic in each and every question, and you have to remember those logics, that if such type of question comes, then you have to use this logic. Okay, so just try to understand how I am doing this question, and you have to acquire that process in your question. This is x cube, a whole upon under root 1 minus x to the power 8. I'm trying to write this x to the power 8 as x to the power 4 whole square. Very first thing which you have to see from here, that which identity this question is requiring. As you see, this is somewhat matching with 1 upon under root a square minus x square dx, isn't it? Because this a can be considered, this one can be considered as a, and this, but they both are not matching. So to make it a square, I'm writing this x to the power 8 as x to the power 4 whole square. Now you understood why I have written like this. Now you consider, let x to the power 4 is equal to t. Differentiate both the side, you will get 4x cube dx is equal to dt. You see, we are going according to the question. We have x cube dx, we got x cube dx. Take 4 that side, so it will be in the denominator. So in place of this, we can write dt by 4, and in place of x to the power 4, we can write t. So finally, dt 1 upon 4, I'm taking it out, under root of 1 minus t square. Now it is very easy for us to solve after this thing. Okay, so 1 upon 4 integration of 1 square minus t square, that is sine inverse t upon 1 plus c. Now put the value of t, that is x to the power 4 plus c. This is the final answer. Okay, now let us come to this question. Integration of under root x upon under root a square minus x square dx. Again, this question is matching with this thing. Sorry. Wait, this is cube, not the square. Now you would be thinking that this is the square, but this is the cube. Even we cannot write anything like cube can be written in terms of square. As of what you know, you are thinking that we cannot write this cube in terms of square, but we can. Just see how we can write a cube. This cube, may I not write cube as like this? If you multiply this 2 with this 2 will cancel, and finally you will get x cube. So how can we write? We write x to the power 3 by 2 whole square. Just to fit into this identity, we have made x cube as x to the power 3 by 2 the whole square. And similarly, can we not do this also to make it a square? Okay, now this is somewhat looking like our identity, our standard integral. Now you consider x to the power 3 by 2 is equal to t. Differentiate both the side. And xn minus 1 identity, have 3 by 2 minus 1 is what? Half. X to the power half means root of x. So I guess you can understand. See, we are getting the things. Take 2 that side, and so root of x dx is equal to 2 by 3 times of dt. So in place of this, we can write this a 3 by 2 the whole square will be same, and in place of x to the power 3 by 2 we can write t, so t square. Now can we apply this identity? Okay, let us sine inverse t upon, will it be like this? Sine inverse x upon a. X is, in place of x we have t, in place of a we have a to the power 3 by 2. Now put the value of sine t as we have taken. So x to the power 3 by 2 and a to the power 3 by 2. Can we write x upon a to the whole power 3 upon 2 plus c? Okay. Now what you can, this 3 by 2 is 1 power and the 1/2 power. So this is only the final answer, no problem in it. Okay. Now the next question, integration of sec square x upon under root 10 square x plus 4 dx. So as you can see that 10 and sec, they both are very related. And differentiation of tan x is sec square x. So the proper substitution here in this question will be tan x is equal to t. Differentiating both the sides with respect to x, sec square x dx is equal to dt. Now this sec square x dx can be replaced with dt, and here tan x, in place of tan x, tan t square, and this 4 can be written as 2 square. Now you know the integration of dx upon under root x square plus a square, that is log of x plus under root x square plus a square plus c. So that is how we have applied the identity, and at last substituted the value of t as tan x, and this is the final answer. Okay, let us come to this question. This is really very different, and it acquires a very different logic. Please try to understand this one. You know, I always tell you, or maybe I don't, but what I do in all the question, I just try to replace the numerator with dt. This we do in each and every question, that we try to replace this this dx, and related, that means in multiplication with this dx we replace it with dt. So to replace this, what I need to substitute, I have to substitute sin x minus cos x is equal to t. This sin x minus cos x, it is nowhere in our question, but by our intuition we are taking sin x minus cos x is equal to t. Now differentiation of sin x is cos x, differentiation of cos x is minus of sin x, so minus plus of sin x dx is equal to dt. See, we got our numerator, and in place of this we can easily put dt. But what to do of this thing? So take your equation what you have taken, sin x minus cos x is equal to t, square both the sides. On squaring, what will be the square of sin square x plus cos square x minus 2 sin x cos x is equal to t square. This is 1, so 1 written. This is sin 2x, so I'm taking sin 2x that side and t square, so 1 minus t square is equal to sin 2x. You have sin 2x with you. Alright, so see, such type of connections you have to make in the question. What you have to learn from this question, that sometimes we have to think some other expression, so that would help us to substitute the things in our question. It is not fixed that from your question only you have to substitute the things. You have to think at some different level also, so you have to face such type of challenging questions. Alright, so you should be ready for that. How can you be ready? I am telling you to do the practice of the examples and the exercise. So up to here we have seen. So this can be replaced with dt, and here in the denominator sin 2x as 1 minus t square. Now introduce this 16 in the bracket, it will be this 9 plus 12, 25. 25 can now the thing is, this t square should be a unity. That means nothing, no coefficient should be there. So take 16 common from the denominator. So 1 upon 16 taken common. So it will be 25 upon 16 minus of t square. Now I think you can do it. This 25 upon 16 can be written as 5 by 4 the whole square minus t square. And you can use the identity 1 upon a square minus t square, that is 1 upon 2a log a minus x upon a plus x, which you know, sorry, a plus x upon a minus x plus c. And after that you can do easily. Okay, let us take this question. Integration of dx upon 2 minus 3 cos 2x. So dx, we have the identity of cos 2x in terms of tan, that is 1 minus tan square x upon 1 plus tan square x. Now one question rises here. What that we can use cos 2x identity as 2 cos square x minus 1 or 1 minus 2 sin square x. You know, you can go with those identities and you just try to reach at that point. You will get the integration of that also, but in a very we can say not in the very proper way. Okay, so that is why we are opting cos 2x as this. Now you would be thinking that how we will get to know that in which question where we have to use cos 2x as that. So you know, we mostly take cos 2x as 1 minus tan square x plus upon 1 plus tan square. Now why? What is the reason why we only take this only? So I'll explain you in the question only. Just try to put here this thing and let us solve. I'll explain you in the question. Take the LCM and this 1 plus tan square will go up and like this. This 1 plus tan square x can be written as sec square x, and on solving this denominator I'm getting this. You know, it is very easy to put tan x is equal to t and getting sec square x dx is equal to dt and replacing this with dt and this with this one. So this is the only reason why we are taking cos 2x as this identity, because it is very easy to handle. See, 1 plus tan square x can be replaced with sec square x, and in the denominator it is very easy to solve when we are getting this and substituting the things like this. So that is why. And if you take 2 cos square x minus 1 or 1 minus 2 sin square x, then there won't be any substitution, you will get a direct. But you know why we studied substitution method? To simplify our solution. So this is the only reason. Okay, after this you can take 5 common and you can use the identity. You know how to do after this. Okay, the last question of the video. Integration of under root x square minus a square upon x dx. So you just see how I have solved this question. Just try to understand what I have done. Here I have done rationalization. This 2 will be x square minus a square and this 2 will be multiplied. Separating, like this is already an identity. Okay, you know that this will become, don't include a square here. This is 1 upon a sec inverse x upon a. So this a with the sec square will cancel. You will get a sec inverse x upon a. So this we already integrated. We are left with this thing. Now here you let x square equal to t. You will get 2x dx is equal to dt, or x dx is equal to dt upon 2. In place of x dx you put dt upon 2, and here under root of t minus a square. So let me just give you the hint for this also. T and minus of a square. Okay, one more thing you can do from here. See, you would have taken x square minus a square equal to t. From here also you will get 2x dx is equal to dt. So x dx is equal to dt upon 2. So in place of this whole we can write t, and you know how to integrate this. This is t to the power minus half dt. So t to the power minus half plus 1 upon minus half plus 1, and at last you put the value of t as x square minus a square. So that's it for today, my dear students. I hope you'll do this exercise 8.7 completely and the exercise 2, and in the next video we'll see the further topic. Till that, thank you so much. Have a nice day. Bye bye.